Hello everyone, in this video we are going to see linked list creating and printing those nodes. In last video we saw several types of linked list involved in computer data structures. In this video we are going to write some C++ programs to create and print the nodes the linked list. Here is my linked list node format. I have one data node, data, and I have next field, data field, and next field will be there in the node. So I'm going to implement in this video is single linked list. So there is only one pointer to denote the next pointer. So we'll create quickly in the C++ code. We jump into the Visual Studio Code. Here I'm going to create this file called linked list cpp. So I have the necessary importings. And using namespace and int main body, just return 0. In this video I'm going to construct this list. It will have 100, 200, 300, 400, 500, and it will iterate through these nodes and print it. Okay, first we'll create the node and then we come back to printing this. So what I need is I need two classes. First is for node and this, then next is for the list. The node you can use structure or class, it's up to you. In this video I am going to use the classes. So classes is the industrial format and industrial standard also. So I'm going to create class list node, and I needed a driver functions, so I'm going to create linked list. Okay, in the list node what I have is I have some public properties. So int data, you can use any data here or data format here. It can be a character or string or anything. In this video I'm going to use integers type of list, so I'm going to use this int data. And the next pointer you need, so need list node and star next. Then I need a constructor, so I'm going to use list node and it expects the int x. So data equals x and then next will be null. Next equals null. Okay, now in the linked list we need two pointers. One is for head and one is for tail. That's also a type of this list node. So why do we need headers from any functions like printing or reversing or finding the middle? We need to start from one node, so we can't go on in between. We can start, so we need this head node and for tail node, because we'll append this. So what we have is, first we'll have this 100, next I'll insert 200. So that time, first time I have the same thing, head and tail will be equal position. When I'm inserting this 200, I linked it, but when I no need to travel from the beginning each and every time. So I'll have reference of this tail node and I'll just give the tail as last node. So that time it will be too helpful for me to insert this. So what I'm going to do is I'm going to take these two pointers. So list node star head and tail, star tail. Okay, my list node is ready. So when I'm instantiating this linked list class, either I need head, or at least one head I need to instantiate. So it can expect the constructor of one, at least one node should be there, then only it is a list. So if it is this data is not there, there is no mean of these functions or throughout whatever it contains. So what I do is I create a constructor linked list, and inside of it expects a list node. So at least one node should be there to perform any operations. So what I'm doing is node n. So I'll assign that head and tail will be n. At the time of the only one node is there, I'll point this head and tail in the same position. So when I'm inserting the next node, I'll just append it to the tail reference. So that's the reason we just at the time of first node creation, we just assigning that n to head and tail. Okay, now it's ready. I have to insert it. In linked list, insertion is literally like append. At the back you can just add those nodes. So what I do is in append I am writing a void append. In append function it expects one integer data because this is same type as what we have this the list node. So int x. So okay, now we need a new node. So list node x1, or you can give y equals to new. This should be a pointer. So new and list node. It expects an integer here. So I'll pass the same integer to this function. So x. Okay. So what we are going to do is tail dot next. Here dot means this is an arrow operator because this is a pointer, so we have to access those properties with the arrow operator for pointers. So tail dot next equals y and tail equals tail dot next. Here you can see I have this node. This is my first node and this is pointed to head at the time. Okay, now I'm creating a new node like this node. So here the head and tail is pointing is the same node, this first node. Okay, now this new node is ready. That's what we have did it in this line number 18. We have created a node and there is nothing. So in this one it is data is 200 and next is null. There is nothing in this because it's instantiated with this constructor as next is null. Okay, now what I do is this head and tail is pointing to the same reference. So what I do is I'm taking this tail, which means this node's next should be this node with the upcoming node. This node is named as y and this node is head and tail. So tails next should be this node. So that's what we have written. Tails next is this our new node called y. Okay, now tail means in the last explanation we saw that it's a last node. So what we do is the tails next is this node, so this should go here. So the tail will come to here. So tail equal to tails next. That's what we have written in the tail equal to tails next. Okay, now this code is ready. This is what this appending function is. Okay, now we'll see the print function. So void print. Printing will always start from the first node. So we'll take this reference and we'll go one by one using this next pointer and we'll print this. I hope you understood this usage of this tail pointer. If we don't have tail pointer, from we'll have only reference to head means when we are inserting the last node again and again we have to travel to the end. When I'm inserting, I'll go here, then only I can. And if I'm inserting here, I have to go to the end and have to add and last also. So in order to avoid those kind of travelings only, we have this tail pointer. Okay, now we'll print it. We have this reference head. So I'll create one more reference variable called t, like a temporary iteration. So this will be equal to head, and while until this pointer is null, I have to continue my execution. Here I'm using C++ 17, so I no need to write this not equal to null. You can just write that t until it holds some address values, something it will execute until it find out the garbage value, then it will come out of it. So this is enough. While t is existing, this one I'm going to print cout, and I'll write t dot data, and I'll give some space, and what I do is t equal to t dot next, because I need to travel this one. Initially I'll be in first position, so this is called t because I'm standing at the end. So once I extract that content, this t dot data, I move to the next, because t's next is this node that's assigned to again t itself. So the t will be moved to this place, so t will come here. So t equal to t dot next in order to move to the next node. So that's also is written. So once I print everything, I just print in on indel. Okay, now in main function we'll create that. Here you can see this linked list class. So I'll give an instant L, and inside of it expects a new node. So because I have forced it to pass at least one node by the time I'm instantiating, so that's the reason I'm passing list node as 1. Okay, now we have this reference to this L, then we can create L dot append. So we can use append. This is coming, and you have to write 2, and then you can go ahead and create 3, 4, 5, 3, 4, and 5, 6. Okay, here I have to write all these functions as public, so I'll write that also because it will be inaccessible at the time it's coming out. Okay, now all errors are gone. Okay, now one thing we have to do is we have to print it. Okay, now print function. Okay, now what you have to do is just format your code and right click, run. Okay, here is my data 1, 2, 3, 4, 5, 6. That's what I have appended in the list. So all my nodes are printed in the console. So this is how you have to create a list node and a linked list class, and you can start to append the functions like this and print the content of it. Okay, I hope you understood this problem and solution, and thank you for watching this video, and we'll meet in the next video.